All right, so we're continuing with section 3.1. That's why it's called B, parallel lines of transversals. We talked about, now we haven't even talked about parallel lines yet, have we? Okay, we've talked about transversals, but we haven't even talked about parallel lines. So that's what we're going to do today. So let's take the stuff that we learned yesterday and parallel lines, and you're going to see how we're going to use this stuff. So we've got a line right here, a line right here. They're parallel to each other, right? Now, I don't think I've shown you this before. Let's do this in a different color. If we want to show that these lines are parallel to each other, we can actually draw a little thing right on the picture itself. So what we're going to do is draw like a little arrow right in there. It's not at the end of the line. It's like somewhere. It doesn't have to be right in the middle. It doesn't have to be to the right. It could be to the left. Just somewhere in here. And usually we put one on top of the other like this. If you put a little arrow in there, that means that those two lines are parallel. All right, so you can't just assume, just because they look like they're parallel, I'll put the little arrows at the end of the lines. Just because they look parallel, you can't make an assumption that they're parallel. They have to tell you that they're parallel to each other. All right, so this could be like line L, line L and line M. They could do this. They could tell you at the beginning of the problem that line L is parallel to line M. We showed you the parallel symbol before, didn't we? I think, yes, no. Some people say yes, some people say no. All right, here it is, right? Whether or not we did it before or not. This is the parallel symbol. It's just two straight up and down lines. That means line L is parallel to line M, okay? Now, if they didn't tell you this, right? So if this wasn't written, oops. Okay, if that was not written down on the homework or the problem or whatever it is, but they did put these little arrows here, that means that they're parallel, okay? If they don't have the arrows here, they would have to tell you that L and M are parallel to each other like I had before. Everybody with me on that? So there's two ways, basically, that you can tell if lines are parallel. If you got the two arrows here, then they would be parallel, okay? Now, let's draw a transversal, and then we're going to talk about what we did yesterday. All right, so here's a transversal, and I'm going to put some angles in here. I don't know. Did we go 1, 2, 3, 4? Is that the way we did it yesterday? Okay, we'll do it the same way. It doesn't have to be like that. I'm just doing it just so we're a little consistent. 6, 7, 8. All right, so yesterday we just learned the names for like the relationship between those angles. Let me push this down just a little bit. But now we're going to learn something a little bit different. Okay? What I want to do is let's talk about the corresponding angles. That's the first one we did yesterday. I'll just shorten it. Is that all right? Just CORR, corresponding angles. Now, we have a thing called a postulate. And we have some theorems. The first one's a postulate, the other ones are theorems. What's the difference between a postulate and a theorem? We discussed that early on in chapter 1.
Postulate, why don't you just accept this true?
Okay, which one is which?
The postulate, just accept this true.
It's exactly right. Okay, the postulate you accept as truth. Okay, they just tell you that this is true. You just believe it's true. All right, that's what a postulate means. You can't really prove it. It's just true, right? Theorems, you can actually prove that they're true, all right? And we'll talk about that here in a second. So I'll tell you what, let's do this. Let's make this a little smaller. I did this yesterday, I think. Oops. Grab it. There we go. I just want to get it, push it off to the side so that I have some room to write all this stuff. And then I can see the picture and I can see all the words, okay? So this is called the corresponding angle. Well, they call it the corresponding angle. If I could. All right. They call it the corresponding angle postulate. And what it says is this. It says, if you have two parallel lines cut by a transversal, every one of the things that we're going to talk about today start the same exact way. If you have two parallel lines cut by a transversal, do we have that situation in this picture right here? Yes, we got two parallel lines, L and M. We got a transversal, which is that red one. right there. Probably should have put arrows at the end of that red one, but that's okay. All right, so we do. So it says if we have that, then what must be true? Here's what the corresponding angle postulate says. If, I'm going to shorten it a little bit, if two parallel lines, so if you have two parallel lines cut by a transversal, right? I'm going to leave that part out just for the sake of all the writing, okay? But if you have two parallel lines cut by a transversal, then the postulate says that the corresponding angles are going to be equal to each other or congruent to each other. Right? So we have to be able to recognize which ones are the corresponding angles, and this postulate tells us that those corresponding angles are going to be equal to each other. They're exactly the same. So what can we write down now? Yesterday we just listed our corresponding angles, but now we can be more specific about those corresponding angles. What must be true about those corresponding angles? They must be what? Equal. So angle 1, we can say now, is equal to what? Angle 5. Very good. All right. So we know that for a fact because of the postulate. If you have two parallel lines cut by transversal, the corresponding angles, 1 and 5, they would be equal to each other. Good. All right. Let's go angle 2. What's angle 2 going to be equal to? Angle 6. Right? And let's do angle 3 is equal to what? Angle 7. Getting the idea now. Angle 4 is angle 8. Okay? So we know that all those things are true. Everybody got it? Good. That's a postulate. How do we know that's true? It's just true. All right? No more than that. Right? You can measure them, I guess, but they would be equal to each other. But it kind of makes sense, though, doesn't it? Like, look at this angle right here. You've got a parallel line. This angle, this transversal is not slanted any different down here, is it, than it is up here. It's slanted exactly the same. So you got this line, and the transversal makes this angle. That same exact transversal makes the same angle because that line is kind of the same, isn't it? All right, it's a parallel line. It's kind of the same. So it just kind of makes sense, doesn't it? That 1 and 5 would be equal, 2 and 6 would be equal, and so forth. Everybody got that? I'm going to do this as well. I'm going to mark these. So 1 and 5 are equal to each other. I got to show you one more thing before I move on. Let's do it now. Here's something that I haven't told you before that I don't think they actually, well, they might have done it in chapter 2. They might have done it then because we skipped chapter 2. So watch this. If I have two lines that intersect each other, this is really important. You're going to be using this a ton. All right. Let's put some numbers in here. Let's call that 1, 2, 3, and 4. Okay. Put arrows on these. Okay. We have a thing that says if you have two lines that intersect each other, do you see how 1 and 2 are opposite each other and 3 and 4 are opposite each other? Everybody see that? See how 1 and 2 are across from each other like this? Yes? No? Any response? I got one nod. That's it. Yes? Do we see how 1 and 2 are across from each other? There we go. Now we got some nods. All right. What about 3 and 4? They're across from each other, aren't they? All right. What do you think might be true about 1 and 2? What does it look like might be true about those two angles? They're equal to each other. They're congruent to each other. Okay? And that's exactly right. I think it's a theorem. I'm trying to think of the proof for this. That's all right. We won't worry about that. I should have been better prepared for this. But all you need to know is that 1 and 2 are equal to each other, and 3 and 4 are also equal to each other. All right? We call those, we have a special name for that. We call them vertical angles. Vertical angles. Right? So our theorem or postulate, whatever it is, I can't remember what it is right now. I should though. But vertical angles are what to each other? They're equal to each other. Okay? So we have a thing that says that vertical angles are equal to each other. So that means in this situation, angle 1 equals angle 2, and what else? Angle 3 is equal to angle 4. Okay? Now, with that said, let's come back up to this, because we had to know this before we could do this. What are some vertical angles here? Let's use the ones that we've already marked with one arc. Okay, so I know that 1 and 5 are equal to each other. What else must be equal to each other? 1 and 4. And why? Give me a reason why. No, they're not across from each other. What are they? Vertical angles. Okay, that's why I wrote that down. This is the reason right here. I mean, they are across from each other, but that's not the reason we're going to use. Our reason is that vertical angles are equal to each other. So 1 and 4 are equal to each other. So if one has one arc, angle 1 has one arc, then angle 4's got one arc. Okay, let's keep going down to here. What about angle 5? 5 and 8 are equal to each other. Everybody with me on that? Okay. Now that means that 4 and what?
1.
Well, I already said 4 and 1 are equal up here, but 4 and 8 are equal, right? And 1 and 5 are equal, right? So all these, 1, 4, 5, and 8, they're all equal to each other. All 4 of those, all right? Give me some reasons, though. Why is 5 and 8 equal? Because they're vertical angles. Why are 4 and 8 equal to each other? Because they're corresponding angles. That's right. 4 and 8 are corresponding angles. And what do we know about corresponding angles? If you got parallel lines cut by a transversal, then the corresponding angles are what? They're equal to each other, okay? So you should be ready to give a reason why those angles are equal to each other. Everybody got it? So 5 and 8 are equal because of vertical angles. 1 and 4 are equal because of vertical angles are equal. Okay, 1 and 5 are equal because corresponding angles. 4 and 8 are equal because of corresponding angles. Got it? Good. All right. What else do we know? We know that 2 and 6 are equal, right? Now, is 2 and 1, are they equal to each other? No. So what am I going to do for angle 2? Am I going to put 1 arc? Put 2 arcs, right. So let's put 2 arcs right there. So let's figure out what else is equal. 2 and what? 3, and give me a reason. Because they're vertical angles. What else? 2 and what else? 6. Why are 2 and 6 equal to each other? Because they're corresponding angles. Okay, it's supposed to be 2 arcs right there. And then 6 and 7, why are they equal? Because vertical angles. That means that 3 and 7 must be equal. We already knew that anyway, though, didn't we? Because they're vertical angles. And 2 and 6 are equal because they're, I'm sorry, I said vertical. I meant corresponding. Thank you. Okay, so 3 and 7 are corresponding, and 2 and 6 are corresponding. You got that? So that's all the stuff that's equal. That's all from the corresponding angle postulate and the vertical angle. I don't know if that's a theorem or a postulate. I got to look that up. Okay? Now, what are some other words that we had? We had, what was the next one we had after corresponding angles? Alternate interior. So let's write that down. So alternate interior, and we're going to call it angle. Now, this time it's not a postulate, it's a theorem because we can actually prove it. And we've we actually proved it already right now. So what does that mean, the alternate interior angles? Which angles are the alternate interior angles? Well, it's either between 3, 4, 5, and 6 because they're the ones that are between the two parallel lines, correct? So 3 and what are alternate interior angles? 6 because they're completely opposite. Everybody see that? So they're alternate interior angles. And what's true about 3 and 6? They're equal to each other, aren't they? All right? And 4 and 5 are also alternate interior angles. And guess what's true about those two angles? They're equal to each other as well. That's kind of a proof. We kind of just proved that the alternate interior angles, so again, if two lines are cut by a transversal, then the what? The alternate interior angles are what to each other? Are equal to each other. Okay? So we really didn't even need them to tell us that, did we? We kind of figured that out on our own, that the alternate interior angles are equal. Now, we had to know that the corresponding angles were equal, right? We had to know that. We had to start off with that, and they told us that that's true. But then we can figure out all this other stuff. What's the other one that's kind of like alternate interior angles? Alternate exterior angles. I'll just put that right here. And then this is also a theorem. So what do you think is... Well, let's list the alternate interior angles. First of all, what are all the exterior? I said interior. I keep messing my words up. Exterior. So what are all the exterior angles here? 1, 2, 7, and 8. Which ones are alternate? 1 and 8. And look what's true about 1 and 8. They're what to each other? They're equal. Okay, what's the other alternate exterior angle? 2 and 7. And guess what's true about those two? They're equal as well. So what do you think my theorem says? It says that the alternate exterior angles are what to each other? Are equal. Okay. Now, this is only true if you have parallel lines cut by transversal. Yesterday, I had two lines that were not parallel, correct? So when I listed all those angles yesterday with non-parallel lines, you could not say that those angles were equal to each other. They're only equal when your two lines are parallel to each other. Okay? That's super important to understand. I didn't write that down for every one of these, but that's what this says. If you have two parallel lines cut by a transversal, I left that part out, then all this stuff is true. We had one more. What was the other one? We had corresponding, we had alternate interior, alternate exterior, and then we had what? Consecutive interior. Consecutive interior. And we call this, guess what? Angle what? Theorem. All right? Let's do a little proof of this before we actually tell you what the theorem says. Okay? Let's take a look up here. Which ones, give me one pair of consecutive interior angles. No, it's not one. That's not interior. One's not an interior angle. Again, you said 1 and 8. I just said 1 is an exterior angle. This says what? Consecutive interior angles. So what's our only 4 choices? 3, 4, 5, and 6. So you can't use 1, you can't use 8, because they're exterior. Look at the interior, the ones that are between these two parallel lines. Okay, I got 3, 4, 5, and 6. Which ones are consecutive interior angles? 3 and 5, yep, they're consecutive interior, and one more pair, 4 and 6, okay? Now, let's see if there's a relationship between those two angles. First of all, are they equal to each other, 3 and 5? No, they're not, because this has 2 arcs, that has 1 arc. This is an acute angle, that's obtuse. Is there any way that they're equal to each other? No. But what we're going to find out, that there is a relationship, but they are not equal to each other. Okay? All 3 of these were all equal. Corresponding angles equal. Alternate interior angles equal. Alternate exterior angles equal. Consecutive interior angles are not equal to each other. Well, there's one situation where there would be equal, but other than that, they're not equal to each other. Okay? What do you think is the relationship between them? They add up to 180. Okay? And you're looking ahead, right? She said supplementary. She's absolutely right. But I don't think we've used the word supplementary yet this year, have we? I don't think we have. But now is the time that we're going to learn it. So, 3 and 5. What I want to do is this. I want to do a little proof. This is a little tiny proof. We're not going to do full-fledged proofs in here. I used to years ago, but I decided when I started teaching math again, we're not going to do proofs. So, you should be very thankful for that, to tell you the truth. But anyway, this is kind of like a mini proof. Let's look at 3 and 5. Let's see if there's a relationship between 3 and 5. Well, let's talk about that. Let's use different colors since I got a lot of marks on here already. Look at 5 and 6. Do you see 5 and 6? What's true about that? They form a what? 180 degrees. Right, a straight angle, 180 degrees. Very good. So angle 5 plus angle 6 equals what? 180 degrees. Agreed? Okay. Now, what else do I know about angle 5? Angle 5, or what am I trying to show? I'm trying to show that 3 and 5 add up to 180, right? So, if 5 and 6 add up to 180, what else is angle 6 equal to? Angle 3, isn't it? You see that? So, I could replace angle 6 with what? Angle 3. So that means that angle 5 plus angle 3, it's also equal to 180. What's true about angles 5 and 3? What's the name of them? What's the name of the relationship between them? They are consecutive interior angles. So what must be true about consecutive interior angles then? They add up to 180. Do you see that? So since 5 and 6 added up to 180, and 3 and 6 were equal to each other, I could replace or substitute, right, angle 3 in for angle 6, since they're the same angle. And that must mean that angle 5 plus angle 3 is 180. Now, when you have two angles that add up to 180 degrees, we have a word for that. Someone give me the word. Supplementary, that's right. When two angles add up to 180 degrees, we use the word supplementary. Did I spell that right? Supplementary. Yep. All right, so we say that they're supplementary. When two angles add up to 180, we say they're supplementary. So let's go back to this theorem. So what do you think I can say about the consecutive angles when you have two parallel lines cut by transversal? You can say that the consecutive interior angles are what? They're not equal, but they are supplementary. Very good. Oops. Let's try it. Supplementary. All right. Why does it keep doing that? Because I'm pushing this button on this pen. I keep accidentally. I wish they wouldn't put that button on there. Anyway, so those are our four. All right. So three of them, the corresponding alternate interior, alternate exterior, three of them, they're all equal to each other. Okay. But the fourth one, the consecutive interior, they are going to be supplementary. And if you look at it, I mean, a lot of students mess this up, and they'll do a problem and they'll set them equal to each other. But they are not equal. I mean, it's almost obvious, isn't it? Because look, this is an acute angle. This is obtuse. Okay, they are definitely not equal to each other. So what's my other choice? They're supplementary, which means they do what? They add up to 180 degrees. Okay, we good with that? Yeah. There's one more theorem before we do an example. Remember I said there's one situation where the consecutive interior angles are equal to each other? Anybody want to guess what that situation is? 90 degrees, exactly. All right, so I'll just do this real quick. We'll go red with the transversal again. But this time, it's not just any old transversal. How did I draw that transversal, do you think? I made a perpendicular, very good. Made a right angle out of it, okay? So now, let's take a look. I'm going to make that angle 1 and angle 2, all right? So here's what the theorem says. I'm not going to write it down. I'm just going to read it to you, and you can just look at the picture and see what it says to do. Now, obviously, these have to be parallel, so I got to put that they're parallel to each other, okay? So it says, if a transversal is perpendicular to one of two parallel lines, is this transversal perpendicular to this one parallel line? Yeah. Then what do you think must also be true? If it's perpendicular to one parallel line, what do you think is true about down here? Then it's going to be perpendicular to the other one as well. All right? That's basically what the theorem says. It's called the perpendicular. Let's try this again. Perpendicular transversal theorem. Okay? And again, it's pretty basic. It just says if you got two parallel lines and your transversal is perpendicular to one of them, it's got to be perpendicular to the other one. Make sense? What must be true about angle 1 and 2 then? What must be true about angle 1 and 2? Say it again. I still can't hear you whispering. They equal each other. Okay, now I hear you. They do equal each other. That's correct. Because if you take a look at this, if this is 90 degrees, what's angle 1 equal to? That's 90 degrees as well, isn't it? Because they add up to 180, right? Because it's a straight line. So that's got to be. And we already said if this is perpendicular here, it's perpendicular here. So angle 1 and angle 2 are what? They're equal to each other. So this is one situation. It's the only situation where the consecutive interior angles are actually equal to each other. Okay? In fact, all the angles are equal to each other, aren't they? Okay, this one, this one, this one, this one, boom, 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 boom. All those, they're all equal to each other, and they all happen to be what? 90 degrees. Okay? Pretty simple, isn't it? All right, let's do an example. We got what? About 14 minutes left. Should be plenty of time to do this. This is in your book, but if you want to write it down, it'd be good. So we got two parallel lines. Guess what? Cut by the transversal. But we actually have two transversals. We got one that's perpendicular, and we got another one that goes through here. Let me slant this a little bit different. There we go. That's not bad. All right, so let's label these. They call it, I'm not going to put arrows on there just for the sake of time, but technically they should have arrows on them. This one is D. All right, let's put some angles in here. They say this is angle 1, this is 5, this is 6. They also say this is perpendicular, by the way. This is 2, 3, and 4. Think that's everything. And we'll put the little perpendicular, or sorry, not perpendicular, but parallel sign right there. So those two lines are parallel. And you got this transversal A, you got this transversal D. It's perpendicular, and we got to find some stuff. We got to find everything. Well, actually, they tell you some stuff. They tell you that angle 1 equals 7y minus 15, and they tell you that angle 2 is equal to 10 times y plus 11. And that's in degrees, and that is in degrees. Alrighty? And now, we got to find all these missing angles. Alright? So, where do we start? Let's do some different color. What do you think? Yeah, angle 5. That's definitely the easiest one. Wouldn't you agree? Right? Because, uh-oh, there goes my pen. Why is it doing this? My pen just died on me. The thing says it's on. If I click the button, there we go. What did I just do? That was weird. Okay, so if this is 90 degrees, and that's 90 degrees, and then this one right here is 90 degrees, right there. Agreed? All right, so angle 5, let's just start writing our answers down. So angle 5 is 90 degrees. So that's one answer. Okay, so we know what that is. Where do you want to go from here? How do you know 1 and 2 equals 180? Okay. Yeah, 1 and 4 are equal. It's kind of weird with that. With this line right here, it kind of messes up a little bit from what we're used to seeing. But we got this parallel line, and this transversal. So that means that 1 and what? 4. Why? Give me a reason. Why are 1 and 4 equal? Give me a theorem or a postulate. You're right. They're corresponding. Yeah, that's a postulate. The corresponding angle postulate. Okay. So 1 and 4 are equal to each other. So we definitely know that. All right. What do we know? Now we don't have angle 4 up here, but what do we know about angle 2? It is equal to angle 3. That's true. But it's supplementary to what? Angle 4. If it's supplementary to angle 4, then it's also what? Supplementary to angle 1. All right? So it's kind of like a little puzzle you got to kind of piece together, right? And you got to think through it a little bit. So we can do this. We can say that. We can put 2 arcs here and 2 here. All right? That might help us out a little bit. But let's do that. So since I got 1 and 2 up here, what's the relationship between 1 and 2? They are supplementary. So let's just do the math. Where can we fit it here? Let's try it. So angle 1 plus angle, let's write it down. Angle 1 plus angle 2 equals what? 180. Now let's plug in the stuff for angle 1 and 2. So if I plug in angle 1, what's that? 7y minus 15 plus angle 2, which is? Yeah, let's write it out. Let's do the actual multiplication. Plus what? 110. And that equals 180, correct? So there's angle 1, there's angle 2, there's my equals 180. Tell you what, just because of time and room, let's solve for y, and you can do the math on your own, but y will equal 5, okay? So you can do the math on your own, but y is going to be 5. So now that should help me find what? Angle 1 and then angle 2, correct? Which one do you think would be the easier one? Angle 2? All right. So what's this? Angle 2 would be 10 times what? 5 plus 11, which is 16, right? And then what's that? Angle 2 is 160 degrees. Everybody with me? All right, so angle 2 is 160. That's another one of my answers. What's another one? Super easy without any math at all. Angle 3 is what? 160. Give me a reason. What's the reason? Because they are vertical angles. They're vertical angles. And vertical angles are equal to each other. Okay, so I know that. Now, I should be able to find angle 4 pretty easy now. So what's 2 and 4 do? They add up to 180, right? So 160. Well, let's just do the math. You know how to do that, right? 180 minus 160, which is 20. And that's angle what? 4. All right, so that's 20. It's degrees, so put degrees in there. What's another one without doing any math that you could find? Angle 1. So angle 1 is also what? 20 degrees. Seen this fun after you find one? After you found y and you found one of the angles, the rest kind of all fall into place after that. What are we missing? Angle 6. So how do I find angle 6? How did I get that? It's a right angle. That's right. So these two add up to what? 90. So if this is 20, what's my math? 90 minus 20 is 70. And that's angle 6 equals 70 degrees. And I think we found them all, didn't we? Yep, we got them all. That's the kind of stuff that they're going to ask you to do. All right? Think you can handle that?
No.
No? I think you can. They actually started off with a pretty good example. I mean, usually they give you like super easy examples, but that one wasn't the hardest one you'll ever do, but that one you did have to think a little bit, so that's good. It's always good to think, don't you think? Let's see, what's the homework? 1 to 21? Yep, so it's section 3.1. It's page 111. And it's 1 to 21. All right, that's it. Have that done for tomorrow.